The second of our hydrocarbons are the alkenes. Now, because there's a lot we need to learn about alkenes, I'm going to break this up into more than one part. So we'll do little bits at a time. The stuff we're going to do today is just going to be based on their functional group, their general formula, and what's called structural isomerism, so how they can have different structures. So the first thing about alkenes is that their functional group is this carbon-carbon double bond. We call that an unsaturated hydrocarbon because we could add something in, breaking the double bond, but still keeping the carbon-carbon bond in place. So there's still what we call a carbon backbone in place when we add something. So these could be chlorine atoms, hydrogen atoms, something like that, where we've been able to break this open. One electron goes there, one electron goes there, and then another element such as chlorine adds an electron as well, or shares an electron with each of those, and we get something added here. So it could be, as I say, a Cl going in here, and a Cl going in here, so that we've got Cl and Cl down there. So it could make a chlorocarbon, or chloroalkane, sorry. So that's what we mean when we say unsaturated. It can have things added to it without breaking the carbon backbone. The general formula, if we were to write a whole lot of these out, and I think there's an example for that in your SciPad, we find that for every carbon, there's twice as many hydrogens. So if there were 6 carbons, there'd be 12 hydrogens. If there were 17 carbons, there'd be 34 hydrogens, that sort of thing. So our general formula is CnH2n. Again, very useful for knowing this for when we've got a formula, but we don't know its structural formula. We just have a molecular formula. We can go, oh, there's twice as many hydrogens as there are carbons. It's almost certainly an alkene. Now, for the first 3 alkenes, drawing them out is quite easy, but once you get to butene, some interesting things happen, and that's where you can have isomerism. We can put the double bond in a couple of different places. So you can see these 2 structures here look a little bit different. The placement of the double bond is different in those 2 molecules. So we need to name them a little bit more specifically. They're both bute because they've got 4 carbons. They're both ene because they've got a double bond, so they're an alkene. But the placement of the double bond means they have a little number with them, 1 butene versus 2 butene. How do we know which one is which? Well, what we do is we number the carbons. Closest to our functional group is the lowest number. So this could be 1, 2, 3, 4, or 1, 2, 3, 4. But if I go this way, the double bond is closer to a low number. It's on a low number. So it's between the carbon number 1 and the carbon number 2. All I do is just choose the lower number of those. So because it's between 1 and 2, I call it 1-butene, because the double bond, the lowest numbered carbon that it's on, is number 1. Here I could go 1, 2, 3, 4, or 1, 2, 3, 4. No matter which way I number it, actually, it's in the middle, so it's going to be on carbon number 2 and 3. If I numbered it the other way, 1, 2, 3, 4, it's still between 2 and 3. So again, I choose the lower of those 2 numbers, and I call it 2-butene, because it's on carbon number 2, between 2 and 3. Now, there is one more structural isomer of this, where I could break this one off, sorry, do it this way, break this one off here to make this a CH3 instead, and chuck it on here as well. That makes this next one, I have to move my camera, I'm sorry, for this molecule here. So I've still got 1, 2, 3, 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So it's still an isomer of butene. But its longest carbon chain is only 3 carbon atoms long. This is what we call a side chain. It's off the side. I can't draw a straight line that links all of them up without doubling anything up. So my longest straight chain is there or there, but I need to include my functional group. So it has to include this one here. So I've got 1, 2, 3 carbons. So it's a propene. It's got this little side chain here, and side chains end in the suffix YL. So we can see the little YL is because of this side chain here. So the side chain's got 1 carbon. So again, using my naming conventions, it's meth. And it's YL is a side group, so it's methyl propene. Now I haven't put any numbers in there. If I wanted to be really, really pedantic, I could say that it's 2 methyl because it's next to the number 2 carbon. 1 propene because the double bond is there. However, and I'll let you do this for yourself, if you try to move anything around there, you'll actually make one of these 2 molecules again. So that's why there's no numbers in methyl propene. What you need to be able to do is to draw isomers for anything up to 8 carbons, but you wouldn't have to do all of them for 8 because there's so many. There's a question in your SciPad which asks you to do it for C6H12. Please do that. There's a lot of possibilities there, and I want to talk about those when we have our conference through Teams.